everyone, I'm Somalpreet Kaur, Assistant Professor in Mathematics, and in this video, we're gonna talk about matrices. So let's begin with its introduction. Suppose we wish to express the information that Priya has 15 notebooks. So we can write this information in form of a square bracket like this. Now suppose Priya has 15 notebooks and 6 pens. Again, we can represent this information in form of a square bracket with numbers arranged in horizontal manner like this. Now suppose Priya has two friends Anjana and Simran and they possess different number of notebooks and pens. Suppose Priya has 15 notebooks and 6 pens, Anjana has 10 notebooks, 2 pens and Simran has 13 notebooks and 5 pens. So we can represent this information in two ways. The first one is this and the second one is this. Let's just see these two kind of representation carefully. So we have this problem. Priya has 15 notebooks, 6 pens. Anjana has 10 notebooks, 2 pens and Simran has 13 notebooks and 5 pens. So first represent was this one. So here the first horizontal line represent the number of notebooks and the number of pen occupied by Priya. So we'll name this as first row. The second horizontal arrangement of number, which is 10 and 2, represent the number of notebooks occupied by Anjana and number of pens occupied by Anjana. So we'll name this arrangement as row 2, second row. And similarly, the third horizontal arrangement of numbers represent the notebooks and pens occupied by Simran. So we'll name this as row third. And if we'll see in a vertical manner, 15, 10 and 13, it represents the notebooks occupied by Priya, Anjana and Simran. So we'll name this as first column. And similarly, the second one represents the pens occupied by Priya, Anjana and Simran. So we'll name this as column, second column. So in this way, this representation gives us the information about the notebooks and pens occupied by Priya, Anjana and Simran. So it's a unique way, it's a great way to write the information in form of this kind of arrangement. The second arrangement is this one. Here 15, 10 and 13 represent the notebooks occupied by Priya, Anjana and Simran. So we'll name this as first row. And 6 to 5 represent the pens occupied by Priya, Anjana and Simran. So we'll name it as second row. Again, this is first column, this is second column and this one is third column. So this is the arrangement. This is a different kind of arrangement of this same data. So let's see what is a matrix. So matrix is just arrangement of numbers in a rectangular array. As you have just seen, we have represented the numbers, we have represented the data, we have represented the possession occupied by Priya, Anjana and Simran in form of rectangular arrangement of numbers. So such kind of rectangular arrangement of numbers is called a matrix. So the numbers which are inside the matrix are called the entries of the matrix. We usually denote matrices by capital letters. The horizontal line of elements are said to constitute a row of a matrix and the vertical lines of the elements are said to constitute columns of the matrix. The following are some example of matrices. For example, you see this matrix A matrix. So A has 3 rows. There are 3 horizontal arrangement of number. Minus to 5 is the first one, 0 root 5 is second one and 3, 4 is the third one. So we have 3 rows here and there are 2 columns. Minus 203 is the first column, 5 root 5, 4 is the second column. Let's see one another example. So this is a different matrix, B matrix. It has 3 rows first row, second row, third row, and first column, second column, and third column. So B has 3 rows and 3 columns. So let's see what is an order of a matrix. A matrix having m rows and n columns is called a matrix of order m cross n, or simply m cross n matrix. It is read by m by n matrix. So if you refer the above examples of the matrix, this matrix has 3 rows and 2 columns. So this is a 3 cross 2 matrix, or 3 by 2 matrix. So A is a 3 by 2 matrix. The second example, it has 3 rows and 3 columns. So this is a 3 by 3 matrix. So the number of rows and number of columns inside a matrix give us its order. And remember this thing, that number of rows is always written first into number of columns is written on the second position. And observe one more thing, that number of elements in this matrix, how many number of elements are there? 1, 2, 3, 4, 5, 6. So we can get the number of entries or the number of elements inside a matrix from its order by multiplying the number of rows into number of columns. So 3 multiplied by 2 is 6. So A matrix has 6 elements and B matrix has 9 elements. So in general, a M cross N matrix has following rectangular arrangement. M by N matrix means there are M rows and N columns. So this side there will be M number of entries. This side, in vertical way there will be M entries, and in horizontal way there will be N entries, because there will be N columns. So it will look something like this. The first row will be A11, A12, A13, so on to Aij, so on to Ain. The second row is A21, A22, A23, so on to A2j to A2n. Similarly, the ith row will be AI1, AI2, AI3, so on to Aij, so on to Ain. Similarly, the last row will be the mth row, and it will be AM1, AM2, AM3, so on to AMJ, so on to last entry AMN. And this is a M by N matrix. Observe here that A11 means first row, first column. So these subscripts represent the row. The first number represent the row, and the second number represent column. So if I have Aij means some ith row and jth column. A23 represent element at second row and third column. So the subscript represent the position of that element in the matrix. So in general, we can write this in this way also. Matrix A equal to Aij, where I is varying from 1 to m because there are m rows, and the I is the position. The I gives us I tells us about the row, and J tells us about the column. So J is varying from 1 to n. So now let's just see in journal how a 3 cross 2 matrix look like. 3 cross 2 matrix has 3 rows, and this side it will be 3 numbers. Vertically there will be 3 numbers, and horizontally there will be 2 numbers. So we'll write 3 cross in journal way. We'll write the 3 by 2 matrix in the following form: A11, A12, A21, A22, A31, A32. So if I see this entry A21, it represents second row and first column. See, this element is in second row, is at second row, and it's in first column. So this is how we generally write. We generally write a matrix. Suppose you want to write a matrix of order 2 cross 2. Suppose you want to write a matrix of order 2 cross 2. In general way, you want to write a matrix of order 2 cross 2. So how you will write it? So in this way, there will be two entries, and on this way also there will be two entries. So we'll write it as A11, A11, A12, A21, because second row and first column, and A22, second row and second column. Again, if you want to write down a 3 cross 3 matrix in a journal way, so you can write it as A11, A12, A13. See, these are the entries of first row. So in subscript, the first number is 1 everywhere. 1, 1, and 1. In first column, the second number is 1. In second column, the second number is 2. And in third column, the second number is 3. Now, when I have to write the second row, I'll write it like A21. The first subscript will be 2 because it's second row. A22, A22, A23, then A31, A32, A33. So in similar way, you can write matrix of any order in journal way. Next is uses of matrices. So how useful is matrix for us? Let's see this. The matrix tool simplifies our work to great extent. It makes our calculation very easy, and it's easier than straightforward methods. It is used in solving system of linear equations. Metric notation and operation are used in electronic spreadsheet program for personal computers, which in turn is used in areas of business and science like budgeting, sale projection, cost estimation, analyzing the result of an experiment, and other things. Many physical operations such as magnification, rotation, and reflections also use matrices. And the main use of matrices is in cryptography, where a code or a signal is is encrypted using a matrix, and then the receiver decrypted and receive the information. So in this way our messages remain secure and safe. Now let's just discuss the type of matrices. The first one is the column matrix. A matrix is said to be a column matrix if it has only one column. For example, if I see this 1 root 5 3, it has only one column and it has 3 rows. So this is a matrix of order 3 cross 1. It has 3 rows but one column. So it's a column matrix. So in journal, a matrix M cross 1 having any M rows and one column is a matrix of order M cross 1, and it's a column matrix. Second one is the row matrix. A matrix is said to be row matrix if it has only one row. For example, 1, 0, minus 1, root 5. It has only one row and it has 4 columns. So it is a matrix of order 1 cross 4, 1 by 4. So in journal, row matrix Aij is Ai by n because it has one row and n column and its order is 1 by n. Third one is square matrix, a matrix in which the number of rows and are equal to number of columns. That kind of matrix is a square matrix. There's a m cross n matrix having m equal to n is a square matrix and it is usually called the matrix of order n. For example, if you see this 2, 0, 4, minus 1, this is a square matrix of order 2. Again, if you see this matrix B, it has 3 rows and 3 columns. So this is a square matrix of order 3. Note one thing, that a square matrix of order n has the elements on its diagonal as A11, A22, so on to ANN, and these elements are called the diagonal of the matrix. Like here, if you see 2 and minus 1, they constitute the diagonal of the matrix, matrix A, and here in matrix B, 1, minus 1 and 1 are the diagonal elements. So they are the diagonal elements or diagonal of the matrix. The next matrix is diagonal matrix. A square matrix is said to be diagonal matrix if all its non-diagonal elements are 0. We say B equal to Bij is said to be diagonal if Bij is 0 when I is not equal to j. So whenever we are talking about non-diagonal elements, so whenever we have to see the non-diagonal elements and they are 0, they come out to be 0, in that case the matrix is said to be diagonal matrix. For example, root 5 matrix 1, 2, another entries are 0, 1, 5, 3, another entries are 0. So leave this diagonal and when the remaining entries are 0 beside this diagonal, then such kind of matrix is called a diagonal matrix. Note one important thing here, that non-diagonal elements must be 0. Non-diagonal must be 0. Diagonal elements can be 0 also. Right? So in a diagonal matrix, the diagonal elements can be 0 also. Okay, but non-diagonal elements must be 0. It's compulsion that they must be 0. But diagonal elements can be 0 also. Can be 0 also and they can be non-zero also. For example, this matrix. Here if you see 5, 0, 1, this is a diagonal matrix. This matrix is a diagonal matrix. But one of the diagonal elements is 0. So in diagonal matrix, diagonal elements can be 0 also. Here you see this first entry is 0. Third entry on the diagonal is 0. So in diagonal matrix, diagonal elements can be 0 also. Okay. Non-diagonal must be 0 and diagonal elements can be 0 or can be non-zero. The next one is scalar matrix. A diagonal matrix is said to be scalar matrix if its diagonal elements are equal. Okay, so if all the diagonal entries are equal, then such kind of matrix is a scalar matrix. For example, if you look here, minus 1, minus 1. The entries on the diagonal are same, so it's a it's a scalar matrix. Again, in this example, you see 2, 2 and 2. All the entries on the diagonal are same, so it's a scalar matrix. There's another definition of a scalar matrix. A square matrix B equal to Bij is said to be scalar if Bij is 0 when I is not equal to j. See, when I is equal to j, that means we are talking about the diagonal elements. When row is equal to column, right? First row, first column. So this is the diagonal element. Second row, second element. Second row, second column. So it's a second diagonal element. So whenever I is equal to j, at that place the element is k. This is fixed k in case of scalar matrix. And whenever I is not equal to j, that means whenever we are talking about the non-diagonal elements, in that case, the element is 0. So this is another definition of scalar matrix, that whenever we are talking about the diagonal elements, they are equal, and whenever we are talking about the non-diagonal elements, they must be 0. Next one is the identity matrix. A square matrix in which elements in the diagonal are all 1 and rest are all 0 is called an identity matrix. For example, if you see 1, 1 0 0 1, 1 0 0 0 1 0 0 0 1, they are the diagonal matrix. They are identity matrix of order 1, 2, and 3 respectively. The next one is a zero matrix. A matrix is said to be zero matrix or null matrix if all its elements are zero, and we denote zero matrix by capital O. For example, this is a zero matrix of order 2, this is a zero matrix of order 3. The next is equality of matrices. Two matrices A and B are said to be equal if they are of same order, and secondly, if each element of A is equal to corresponding element of B. For example, if you see 2 3 1 2 and 2 3 1 2 are equal, but 2 3 1 2 and 2 4 0 2 are not equal, because this element is not equal to this element, and this element 1 is not equal to 0. So these two matrices are equal, but these two matrices are not equal. Thank you viewers for watching this video. I hope you like it. Kindly like and subscribe my channel and use the comment section below to ask your problems. I hope you like this video. Have a good day. Thank you.